Okay. Now, just moving to actually nitty-gritties of analytics. One of the, this is where actually analysts try to cheat the business users. So I thought I should indicate a few of them. The first one is you have to be, in most of the times when you are predicting in future, there can, particularly in classification, there are two different types of errors. Let us say you want to do a call campaign and you asked an analytics team to tell which customers are likely to respond to your calls. So you have this 10 million phone numbers. You have people only to make 1 million calls. So you ask them, hey, tell me which 1 million are the most likely to respond to my offer. Then the analyst can make two different types of errors. The good thing that he can do is he can tell, hey, these will respond and these will not respond. But he or she may say someone will respond, whereas in reality they will not respond. And he or she may say someone will not respond, where in reality they will respond. Now, these are called false positive and false negative. Obviously, you can see that the loss is very, very different from both types of errors. If someone will respond, if he said someone will respond, and even if they don't respond, all you waste is a call. Probably you spend 50 paise. They don't respond, but you thought they would respond. They'll just shout and they'll put the phone down. It's 50 paise. Whereas if he says someone will not respond, but in reality he would have bought your $5,000 product, you lost $5,000 on each error. In first type, you lost 50 paise on each error. In the second type, you lost $5,000 in each error. So it's extremely important when you are getting into future predictions and classifications to know what kind of errors you cannot are a lot more dangerous to your system and what kind of errors are not. Then there is one more error that analytics people commonly have, and that is fundamental to the problem that I am having some data points and I'm trying to predict some future value of the data point. So let's say I have a data point, set of data points like this. I can fit some a-line function like this. You see that this has a lot of error. It's a lot of error. Then there is another, this is called bias. There is a lot of error in your model. You can also fit like this. This has zero error on this data, but that's never your goal. Getting a zero error on the data that you have is not the goal of a data analyst. What I want to have is what is the future, on future data, how much of error I will have. And a function like this is called highly overfitted. Most data analysts get really carried away when they are doing data analysis and they come back and say, hey, I have a 99% accuracy. In fact, it is not uncommon for me to have fresh MSc grads or MTech grads who come and say, hey, we got 100% accuracy on the data. And then I say, you are God then. We cannot overestimate our ability to fit the data, and the struggle of an analytics project is to identify that model which has little error, as little error as possible, and as little overfitting as possible, as shown in this diagram. So another very important care that one has to take is to be extremely careful that we are looking at existing data and making predictions about non-existing data, and hence a different set of problems arise in reality. There is another thing called curse of dimensionality. Let's not worry about it in the interest of time. I just want to talk